In this video, we'll be talking about summation notation, or more formally known as sigma notation. This E-looking thing here is denoted as the Greek letter sigma. If you identify that there is a variable below it, this right here is identified as the index. So the index for this particular sigma notation is I, and we're going to go ahead and start this at 1. We're going to go to 6, and the function that's going to be inside is I. So this is example number 2, as you can see, and what it really identifies is the function I'm playing with is this right here. I'm going to start at 1, and I'm going to end at the 6th term, or 6 terms after 1. So I'm going to plug 1 into the function, and that's going to give me, well, 1. Again, 1 subbed in for I is 1. This summation, the sigma, is actually telling me that I'm supposed to add this next term together. So I started at 1, I want to go all the way to 6. So I started at 1, I now need to plug in 2 to this function. When I plug in 2 for I get 2. So this is when I plug in 1, this is when I plug in 2. I'm going to add, then I'm going to go ahead and continue to plug in the numbers up until I get to 6. So plug in 3, then 4, then 5, then 6. And again, you'll notice this, that it goes 1, 2, 3, 4, 5, 6. I have an addition sign between each piece, and the reason why it's just the number is because the formula is just I. So this right here is actually example number 2a. For 2b, we're looking at the summation such that we start at I equals 0, and we go out to 5, and the function I'm playing with is I plus 1. So now, you'll notice that the parentheses around this sigma notation tells me that I'm actually going to go ahead and do this entire function at 0, and then 1, 2, 3, 4 until I get to 5. So I'm going to go ahead and plug in 0 first. When I plug in 0 first, I get 0 plus 1. Now I know you can simplify this here, but I'm going to go ahead and leave it out so you guys can see the pattern. I'm going to add to that when I plug in 1. Now when I plug in 1 to this function, I get 1 plus 1, which is 2, I know, but I'm going to go ahead and write it as 1 plus 1. And then plus, I'm going to go ahead and plug in 2, because I plugged in 0. I plugged in 1. I'm going to plug in 2 next. Then 3. Then 4. Until I get to, again, one more time, the last value here, which is actually 5. You'll notice at this point that I get 1 plus 2 plus 3 plus 4 plus 5 and plus 6. And you'll see, I hope, that these two summations are actually the exact same thing. Notice 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, what's the thing that makes these two exactly the same? Well, you'll notice here that the function goes from I to I plus 1. But out here on the bounds, it starts at 1 and it goes to 6. Well, down here it starts at 0 and it goes to 5. So you'll notice the bound from here to here on the bottom, the lower bound, and from here to here, the upper bound, we are actually subtracting 1 from those two pieces. But then in here, I am replacing this I with I plus the 1. Okay, so you'll notice again on the bounds, I subtract 1. On the interior, I add 1. This actually happens reverse, so if I wanted to go ahead and change this to start at 2, I would have I equals 2. Summation 2, again, I'm adding 1 to this bound, so I'm going to add 1 to this bound up here, changing that to a 7. But inside here, instead of having just I, I'm going to subtract 1 from I. And you'll notice if I plug in 2, I get back 1. That's the first term. If I plug in 3, I get back 2, and so on and so forth until I plug in 7 and I get back 6. So this summation would actually be the same. Now again, that's extra notes, that's not necessary, but it's good for us to identify and understand how we can manipulate these summations.